Now in the previous lecture, we have learned how to search for a string in a trie. Now in this video, we are going to talk about deletion of a word in trie. Now similar to insertion of string in a trie, in case of deletion, we have 4 cases over here. So let's see them one by one. So case 1 is we want to delete a string whose prefix is same as the prefix of some other word over here. We mean that, so if we look at this trie over here, we see that we have 2 words over here. One word is API because after I we have end of string over here, and another word is apple. So here A and P are common to these 2 words over here. So this means that whenever we are deleting API from here, we cannot delete A and P because A and P are also first elements of apple over here. So in this case, whenever we are deleting a word from trie, the first thing that we are going to do, we are going to check that if this word exists in this trie over here. So as always, we are going to check the root node with the first character, then the second node, then the third node, and it continues like this until we have find all characters over here. So here we can easily see that API exists in this trie over here because after I we have end of string over here. So whenever we are deleting a string from trie, we are always starting from the leaf node. So we cannot start from the root node, so we are going to start from the leaf node. So this means that if you find API over here, the first thing that we are going to do, we are going to check the leaf node and see that if any node depends on this node over here. So in this case, we see that there is no any node that depends on this leaf node over here. So this means that we are going to delete this leaf node from here. Now after deletion, we are going to continue to the parent of this leaf node. So in the parent, we have I. So this I is not linked to any node over here. So in this case, this means that this is independent node. So we are going to delete this one as well. Now after deletion, we are continuing to do P. So in this case, we see that there is some other node depends on P over here. This means that P over here serves as a node for other string over here. So we cannot delete P from here. So with this, we have successfully deleted API from this trie over here. After deletion, if we search for API, we see that we can find only A and P. So we cannot find I and end of string. So this means that we have successfully deleted API from this trie over here. Now let's continue to the second case. Now the second case is the string is a prefix of another string. So this means that, for example, if we want to delete API from here, we see that we have another word which is API-S. So this means that API serves as a prefix of another string over here. So in this case, how can we delete API from here? So in this case, the only thing that we are going to do, we are going to delete the end of string in this case, because here we can easily find out that API exists in this string because after I we have end of string over here, and this API serves as a prefix of another string. So this means that the only thing that we are going to do, we are going to delete the, so if we set it to false, it's going to be like this. So in this case, if we search one more time for API, we can easily identify that A exists over here, P exists over here, and I exist over here, but after I, we don't have end of string. So this means that this API over here will not be recognized as a complete string. So we have successfully deleted API from here. So with this, we have implemented second case as well. So let's continue to the third case. So in the third case, other string is a prefix of this string. So here, let's say we want to delete API-S from this trie over here. But here we can see that there is another string which acts as a prefix of this string. So if we want to delete API-S, we see that there is API. There is API serves as a complete string over here. So this means that whenever we are deleting this API-S from here, so we cannot delete the first 2 letters over here because first 2 letters serves as a complete string over here, because after P we see that we have end of string over here. So in this case also we are going to start to delete from the leaf node. So in the leaf node we have end of string, so we can successfully delete this one from here. So as you can see, after S we don't have end of string, so this means that we are going to continue to delete S from here. Now in this case, S is a leaf node, so there's not any node depends on this S over here, so we can easily delete this S from here as well. So after deletion, our trie will be like this. So here again, after AP we need to keep the end of string, but here we need to delete I from here. So this means that we are going to set to this empty node. So I is removed over here. So AP remains over here as a complete string. Now let's continue to the fourth case. So in the fourth case, not any node depends on the string. So in this case, for example, if we want to delete K from here, so we can easily see that in this trie over here, we have 3 words. So the first word is AP, because after P we have end of string over here. The second word is API S, because after S we have end of string over here. And the third word is K. So after K we have end of string over here. Now here you can easily see that we don't have any node that depends on K. So this means that we can easily delete K from here. So in this case we are going to delete the leaf node of K over here. So after deletion it's going to be like this. Now after deleting is we have to delete the K. So in this case if we delete this complete node from here, it's going to delete the A as well. So in this case we are just going to set the value of this node to A. So after deletion it's going to be like this. So we have successfully deleted K from here. So these are the 4 cases that can happen when we are deleting string from Trie. So on a high level, when you delete a string from Trie, we just need to make sure that not any node depends on this character over here. So if there is any node that depends on this character, on this node over here, we cannot delete them straight away. We just need to do some adjustments that we have done in case of 1, 2, and 3. Now based on the logic that we have discussed over here, let's head over to Java and create deletion method for Trie. Now here inside Trie class, I'm going to create delete method for deleting a string from Trie. Now here we are going to create 2 methods. So the first method will be helper method and the second method will be the delete method. So first I'm going to create helper method, then we are going to create main delete method. So the helper method will return boolean. So it's going to return true if the parent should delete the mapping. So in this case it's going to be like this, boolean delete. So in this case the first parameter that's going to take is going to be the Trie node. So it's going to be the type of Trie node and we are going to put it as a parent node. Then the second parameter will be the word that we want to delete. It's going to be string type word. Then the last parameter will be index. So we are going to put the index to loop to check the characters one by one, because in case of Trie we are storing the characters in each node. So that's why we are going to use index over here. Now as we said before, we have 4 cases in case of deletion. So we are going to implement 4 cases one by one. Now before implementing 4 cases, I'm just going to create a character variable over here and take the word character. Then we are going to get the current node based on this character. Then I'm going to create a variable which shows that this node can be deleted or not. So it's going to be boolean variable. So if it is true, we can delete this node. If it is not true, we are not going to delete that node from the Trie. So in this case it's going to be like this, char ch is equal to, which stores the character that is located at this index that comes from this parameter over here. Then the next variable will be Trie node, which will keep the current node's value. So in this case it's going to be like this, parent node dot children dot get. We are going to use get method. So by using get method we are going to get the node of this character over here. Then we are, as I said, we are going to create a boolean variable which will be, can this node be deleted? So if it is true, we are going to delete that node. If it's not true, we are not going to delete that node. So here we are going to implement 4 cases as I mentioned. So the first case is some other word's prefix is same as prefix of this word over here. So how can we check that? So in this case we are going to check that if current node's children's size is greater than 1, in this case it means that for a current node we have more than 1 child. So this means that this is serving as a prefix for other word as well. So in this case it's going to be like this, if current node dot children dot size is greater than 1, in this case this is the first case. So in this case we are not going to delete this node, we are just going to continue to the next node. So to continue to the next node we are going to call this delete method recursively for index plus 1. So in this case it's going to be like this, delete. So as a node we are going to pass the current node because this is the parent node of the next node. So that's why we are going to pass it as a parent. Then we are going to pass word and it's going to be index plus 1. Now after doing so we have to return the boolean variable. So we are not going to delete this node. So that's why we are returning false. Now with this we have successfully implemented our first case. Implementing the first case we are going to continue to the second case. So the second case is we are at the last character of this word, but this word is a prefix of some other word. So in this case how can we check it? So we can check it that if the index is equal to the word length minus 1, in this case we are at the last character of this word. And if the children's size is greater or equal to 1, in this case, this means that we are just going to update the end of string to false, and we are not going to delete this node from here, so that's why we are going to return false. So it's going to be like this. If index is equal to word.length minus 1, so this means that we are at the last character of this word. So in this case, we are going to check that if current node dot children dot size is greater or equal to 1, in this case, this means that this word is a prefix of some other word. So here we are just going to update the current node's end of string to false, because in this case we need to delete only this string, but this string serves as a prefix of the other string. So this means that we are just setting the node's end of string to false to make this string incomplete string. So that's why I'm going to put it end of string to false. Now after doing so, as I said before, we are not deleting this node, so that's why we are going to return false. Now here, there might be another cases that if we are at the last character and this is not a prefix of some other word, in this case we have to remove this character. So that's why in the else condition, I'm going to remove that one from these children over here. So it's going to be like this. Parent node dot children dot remove. So we are going to remove this character. Then after removing, we are going to return true because we have deleted this character from here. So with this, we have successfully implemented our second case also with this if condition. Now we are going to continue to the third case. So the third case is some other word is a prefix of this word. So how can we check that? So we can check it by using this if condition. So it's going to be like this. If current node dot end of string is equal to true, this means that some other word is a prefix of this word over here. So in this case, it's going to be like this. We are just going to call this method recursively for the next character. So as we did over here, we are going to do the same thing. So we are going to call this method recursively for the next character. Now after calling recursively for the next character, we are going to return false because here again, we are not deleting the node over here. So after doing so, we are going to continue to the third case. Now the fourth case is no other node is dependent of this word over here, so we can successfully delete this. So in this case, I'm just going to use the can this node be deleted. So the value that we are receiving from this recursive call, we are going to assign it over here to this variable over here. Then we are going to use this variable to delete node from here. So if this variable is equal to true, we can delete this node. Otherwise, we cannot delete this because in this case, someone is dependent on this node over here. So it's going to be like this. If can this node be deleted is equal to true, this means that we can delete this character from here. So it's going to be like this. So I'm just going to copy it from here, pass it over here. Parent.children.remove. We are removing it. So after removing, it's obvious that we need to return true. Otherwise, we are going to return false because there is some other node that is dependent on this node. So we cannot delete this node over here. So it's going to be return false. So with this, we have successfully implemented our method over here. So as I said before, this is helper method. So I'm going to create another method, which will be the main delete method over here. So I'm going to declare this method like this. So public void delete. So this method will take only one parameter because we are just going to delete the string from the trie over here. So first we are going to search for this word inside trie. So we are going to do it by calling search method. So if search word is equal to true. So as you remember, when we are creating search method over here, it was returning true. So if the word exists in this trie, it was returning true. Otherwise, it was returning false. So this means that if search word is equal to true, so we can call delete method that we created for root word, and it's going to start from the index of 0. So with this, we have successfully implemented our method over here. Now let's see how this is working in practice. Now here inside main class, we have created a trie over here, and we have inserted two words to this trie over here. So the first word is API, and the second word is API-S. Now if I call search method for this trie over here for API-S, you'll see that it's going to return that API-S is exist in this trie over here. So I'm just going to call the search method. So let's call it for API-S. So if I run our code, you'll see that it says that API-S exists over here. So you see that the word API-S exists in this trie over here. So what I'm going to do, I'm just going to delete this APIs from this trie over here by using delete method that we created. Then one more time, I'm going to call search method to see that if it is exists after deletion or not. So if it does not exist, it means that we have successfully implemented our method. So it is successfully deleted APIs from over here. So after deletion, I'm just going to call search method one more time to see the differences. So if I run our code in this case, so you see that when we are calling APIs, first it says that APIs exists in this trie. So you see that when we are calling first for APIs, it says that APIs exists in this trie over here. Then when we are calling delete method, inside delete method, it calls search method one more time. So that's why it prints out to the console saying that APIs exist over here. Then after deletion, when we are calling the search method, it says that APIs does not exist in this trie over here. So this means that we have deleted a word in which we have some other word as a prefix. So in this case, for example, instead of APIs, if I delete the API and run search method for API, you will see that this case also implemented successfully. So if I run our code, so after running it, first we see that APIs exists in this trie over here when we are running the delete method, because first it's checking that if it exists or not. Then when we are deleting it, after deletion we are running search method, so we see that APIs does not exist in trie, but it's a prefix of another string over here. So this means that we have successfully deleted API end of string in this API over here, but we have not deleted API characters over here because API serves as a prefix of APIs over here. So with this, we have come to the end of this lecture. So in this lecture, we have implemented deletion method in trie. So as I said before, we have implemented 4 cases over here. So hopefully everything is clear about deletion of a string in trie. So see you in the next lecture.